Welcome back to the course on nutrition and planetary health, presented by the Physicians Association for Nutrition and PANCO. This course provides an evidence-based foundation for how dietary patterns influence both human health and planetary health, and how this knowledge can be applied in clinical practice to promote healthy and sustainable diets. Let's begin with the third module on the environmental impact of diet. In this module, we examine the concept of planetary health and the role of food systems in driving environmental change. Ready to dive in? Let's get started with Lesson 1 on the planetary health and nutrition. Before you begin this lesson, please answer the following question. This ungraded question is designed to get you thinking. If you are unsure, take your best guess. Which of the following environmental changes has measurable implications for human nutrition? A. Rising atmospheric carbon dioxide. B. Increasing frequency of extreme heat events. C. Degradation of soil and freshwater systems. D. All of the above. The correct answer is D. All of the above. Planetary health is not a distant environmental concern. It shapes the conditions under which food is produced, distributed, and consumed. In this lesson, we examine what planetary health means and why it matters directly to nutrition and clinical practice. The Rockefeller Foundation Lancet Commission on Planetary Health defined planetary health as the health of human civilization and the state of the natural systems on which it depends. This definition reframes health as inseparable from ecological stability. Human well-being depends on climate regulation, biodiversity, fertile soils, freshwater availability, and functioning oceans. The 2025 Lancet Commission further emphasizes that food systems are both a major driver of environmental change and a central lever for improving health outcomes. Diets influence greenhouse gas emissions, land use, freshwater withdrawals, and nitrogen and phosphorus cycles. At the same time, environmental degradation feeds back into diet quality, food security, and disease risk. Planetary health, therefore, provides a systems-level lens for understanding nutrition. The Planetary Boundaries Framework was developed to define a safe operating space for humanity. It identifies 9 Earth system processes that regulate planetary stability. For each process, scientists propose quantitative thresholds beyond which the risk of destabilizing feedbacks increases. Let us briefly look at each boundary in turn. The first boundary is climate change. Climate change is driven primarily by rising atmospheric concentrations of greenhouse gases. Pre-industrial carbon dioxide levels were approximately 280 parts per million. By 2023, concentrations exceeded 420 parts per million. The planetary boundary for climate is expressed through metrics such as atmospheric carbon dioxide concentration and radiative forcing. Current levels exceed the proposed safe boundary. The global average temperature has already increased by approximately 1.1 degrees Celsius relative to pre-industrial levels. For clinicians, consider these implications. Increased heat exposure raises risks of heat stroke and cardiovascular stress. Altered precipitation patterns influence vector-borne diseases. Agricultural yields are affected. Climate is not an abstract variable, but a determinant of population health. The second boundary is biosphere integrity. Biosphere integrity refers to the diversity and functioning of living systems. It has 2 components: genetic diversity and functional diversity. Current extinction rates are estimated to be tens to hundreds of times higher than background rates. The boundary for biosphere integrity has been substantially exceeded. Why does biodiversity matter for nutrition and health? Biodiverse systems contribute to pollination, soil fertility, water purification, and disease regulation. Loss of biodiversity can destabilize food production and increase the risk of zoonotic spillover. The third boundary is land system change. Land system change primarily refers to deforestation and the conversion of natural ecosystems to agricultural or urban use. Approximately 75% of the Earth's ice-free land has been significantly altered by human activity. Forest cover has declined substantially in many regions. The planetary boundary for land system change has been crossed in several biomes. Land conversion affects carbon storage, regional rainfall patterns, and habitat stability. For clinicians, these changes can affect food production, air quality, and infectious disease patterns. The fourth boundary is freshwater change. Freshwater is essential for drinking, sanitation, agriculture, and ecosystem function. The updated framework distinguishes between blue water, such as rivers and groundwater, and green water, which refers to soil moisture available to plants. In simple terms, this means both the water we can extract and the moisture crops depend on are under pressure. Human activities have altered freshwater cycles at regional and global scales. Large river systems are increasingly regulated, and groundwater depletion is widespread. Water scarcity affects crop yields, food prices, and sanitation infrastructure. It also increases vulnerability to waterborne diseases. The fifth boundary is biogeochemical flows. Nitrogen and phosphorus cycles have been profoundly altered by synthetic fertilizer production and intensive agriculture. In simple terms, this refers to how human activity has disrupted the natural movement of nitrogen and phosphorus through soils, water, and ecosystems. Anthropogenic nitrogen fixation now exceeds natural terrestrial fixation. Excess nitrogen and phosphorus runoff contribute to eutrophication, harmful algal blooms, and dead zones in aquatic systems. These changes affect water quality and fisheries, with downstream implications for nutrition and livelihoods. The sixth boundary is ocean acidification. Oceans absorb approximately 25% of anthropogenic carbon dioxide emissions. This absorption lowers seawater pH, a process known as ocean acidification. Reduced pH impairs shell formation in marine organisms such as corals and shellfish. Coral reef degradation affects fisheries and coastal protection. For populations that rely on seafood, this has direct nutritional implications. The seventh boundary is stratospheric ozone depletion. The ozone layer protects life from harmful ultraviolet radiation. International agreements such as the Montreal Protocol have significantly reduced the use of ozone-depleting substances. This boundary illustrates that coordinated global policy can reverse environmental harm. It provides an example of successful planetary stewardship. The eighth boundary is atmospheric aerosol loading. Aerosols influence climate and human health through air pollution. Atmospheric aerosol loading refers to the buildup of fine particles in the air. Exposure to fine particulate matter is associated with increased cardiovascular and respiratory morbidity. While this boundary varies by region, air pollution remains a major contributor to global mortality. The ninth boundary is novel entities. Novel entities include synthetic chemicals, plastics, and other human-made substances not previously present in Earth systems. Plastic pollution and persistent organic pollutants accumulate in ecosystems and food chains and affect environmental quality, biodiversity, and human exposure through food systems. The boundary for novel entities is considered to have been exceeded. Recent evidence shows that 6 of the 9 boundaries have been transgressed: climate change, biosphere integrity, land system change, freshwater change, biogeochemical flows, and novel entities have crossed their proposed safe thresholds. Let's now discuss how planetary health affects nutrition and health. Environmental degradation affects nutrition through multiple interacting pathways. This includes through agricultural productivity and food availability, nutrient quality of crops, food prices and economic access, and non-communicable diseases and mortality. Observed global warming has already reduced yields of major crops in several regions. IPCC 2023. Extreme heat during critical growth periods can reduce wheat and maize yields. Climate-related yield variability increases the risk of supply shocks, particularly in regions highly dependent on rain-fed agriculture. Disruptions to production undermine food availability and stability, both of which are key pillars of food security. Elevated atmospheric carbon dioxide affects not only crop yield, but also the nutrient composition of crops. Smith and Myers estimated that rising carbon dioxide concentrations could reduce zinc concentrations in major staple crops by 3 to 17%, and iron concentrations by 4 to 10%. They projected that 175 million people could become newly zinc deficient and 122 million newly protein deficient under mid-century carbon dioxide scenarios. This pathway is particularly concerning because micronutrient deficiencies may increase even if caloric intake remains adequate. Climate-related production shocks can also increase global food prices. The IPCC reports that extreme events have already contributed to price spikes in international food markets. Owino and colleagues describe how climate-induced disruptions affect food affordability, particularly in low-income settings. When food prices rise, households often shift toward cheaper, energy-dense and nutrient-poor foods. Such dietary substitutions may increase risks of both undernutrition and obesity, reinforcing the double burden of malnutrition. Springman and colleagues also modeled the health impacts of climate-related changes in food availability and estimated approximately 529,000 additional deaths globally in 2050 under certain climate scenarios, largely mediated through reduced fruit and vegetable availability and increased prevalence of underweight. Environmental change and planetary health, therefore, interact with dietary risk factors for cardiovascular disease, diabetes, and certain cancers. In simpler terms, environmental change does not replace these risks, but can amplify them. Planetary health provides a systems-level lens for understanding nutrition. Ecological stability underpins every dimension of food security and diet quality. For clinicians, these connections strengthen preventive care and place dietary advice within the broader determinants of health. Environmental changes such as climate instability, biodiversity loss, and altered biogeochemical cycles influence food availability, nutrient quality, disease patterns, and health equity. Planetary health is therefore very much relevant and important for clinicians and healthcare systems. In the next lesson, we will look more closely at how food systems affect these planetary boundaries and how dietary shifts may support both human and planetary health. Before we wrap up this lesson, let's look at the key takeaways to recap what we learned. Planetary health refers to the health of human civilization and the state of natural systems on which it depends. The planetary boundaries framework defines environmental limits within which humanity can safely operate. Several of these boundaries have already been exceeded due to human activity. Environmental changes such as climate change, biodiversity loss, land system change, and freshwater disruption influence food production, food prices, and the nutritional quality of crops. These environmental pressures can increase risks of food insecurity, micronutrient deficiencies, and diet-related non-communicable diseases. Understanding planetary health helps clinicians recognize the broader environmental determinants of nutrition and health. This strengthens prevention and systems-based thinking in healthcare. Before you move to the next lesson, let's assess your learning through a quick question. Based on what you learnt in this lesson, answer the following question. Which of the following best explains the relationship of planetary health with clinical nutrition practice? A. Environmental degradation only affects future generations, not current patients. B. Planetary boundaries are primarily ecological concepts without measurable health implications. C. Environmental changes such as climate instability, biodiversity loss, and altered biogeochemical cycles influence food availability, nutrient quality, disease patterns, and health equity. D. Planetary health is mainly concerned with wildlife conservation rather than human well-being. The correct answer is C. Environmental changes such as climate instability, biodiversity loss, and altered biogeochemical cycles influence food availability, nutrient quality, disease patterns, and health equity. Planetary health matters in clinical practice because ecological systems underpin food systems, disease patterns, and health risks. Understanding these connections strengthens preventive care and places dietary advice within the broader determinants of health. In this lesson, we examine the concept of planetary health and the planetary boundaries that define the environmental limits of human activity. However, one important question remains. How do human food systems interact with these planetary boundaries? Food production, processing, distribution, and consumption are deeply connected to environmental change. At the same time, dietary choices offer an important opportunity to support both human health and environmental sustainability. In the next lesson, we will examine how food systems influence planetary health, including the environmental impacts of different dietary patterns and how dietary shifts can support both human and planetary well-being. We would value your feedback. Please scan the QR code on screen to share your thoughts on the course content and help us improve this learning resource. Thank you for watching this lesson. This is the course on nutrition and planetary health, developed and presented by the Physicians Association for Nutrition and PANCO. You can now move on to the next lesson.